Thank you very much. And today, actually, I'm going to present two projects. As my big boss, David William, he's away. That's why I have to present also part of his work. However, my biggest challenge is I'm not sure you have any brain left. Today was a very knowledgeable day. And all your brain must be very saturated and see how it goes. And anyway, my brain is very saturated. So if I behave a little bit different way, please excuse me. Okay. Just to start with, as this topic is self-explanatory, we are working on biological control of codling moth and also mass trapping of codling moth. And our team actually did, like is a last 20 years on mass trapping or attract and kill strategy. Our team actually did pretty good job, and that actually internationally recognized, as we mentioned. Also, Angus also mentioned there, as we actually imported one. This is a wasp, and as a biological control agent, this came all the way from Kazakhstan. It's a very rough and tough country, but it actually came through many countries. Unfortunately, this is actually in very comfortable situation last 20 years. As it's not in rough situation. We are doing in the lab, and that's why our challenge is now we did all the lab work. Now we actually planning to release in the field situation. I will explain a little bit further, and then finally. Mass trapping is also, as I mentioned this, as most of you know that mass trapping is important. The reason is we actually, in this case, attracting both males and females of codling moth. Okay, like as I said that, PIPS 1 is finished, and on that PIPS 1 part of that one was, as Oscar actually did good job, and maybe a little bit easy for me now, hopefully. And the target was sustainable IPDM in orchards. And on that one, we were trying to do, as I mentioned, biological control of codling moth. And this is to supplement mating disruption. As you understand, in nature, what happened is that mating disruption was doing good job until and unless the codling moth population started to increase. Or if our initial population is low, and then mating disruption would do good job. So that's why our target is by using this wasp, if we can control some of the population, especially in the winter time, which is diapposing larvae at that time, and hopefully starting population low, and our mating disruption should work reasonably well. That's actually our target. And obviously, we also planned in that project, or first phase of the project, biocontrol of woolly apple aphids, and like just to supplement Aphelidinas mali, which was doing good job, and also. Oscar mentioned already scab management, and also understanding the interaction between various things. As you understand that the nature is very complicated, and insect, plant, soil, and also various management issue we have, or management thing we deal, everything interact each other. So more we understand, it's easy for us to manage our system. And obviously, our achievement is, as we mentioned initially, as this wasp or mustras is been imported, and it has been tested in the lab. As you understand, this Australia is very vigorous on the, to give the permit. So that's why we did 4 or 5 years lab test, and then we actually were lucky to get the permit to release in the field. And also Heringia, which is biological control agent of woolly apple aphids, also been reviewed, and scab is covered already, and interaction also been reviewed and reported. And as I mentioned that this mustras actually released in New Zealand and also here in Australia. In Australia, we had 2 releases, one in May and one was in August. The May one was a smaller scale, but August one we did more than 15,000 mustras released in a particular block in Shepparton region. The block we released mustras is very heavily infested with codling moth, and that was anyway, and so that's the block we released. And since I got a sign that time is running fast, so I also move fast. So as I said that we actually released in three blocks. I will actually show a little bit more details, as we actually used these plastic containers, or it has several holes in the bottom and also on the sideways, and this just to protect them from the predators and also several other things. So we actually released them in the middle of the block. As each block we had 5,000 mustras, And then we also have sentinel, band with Codling moth larvae, just to understand how far they removed and how actually they did it. The we actually found, and after 2 weeks, this band actually taken to the lab, and then we found that almost, more than 42 meters actually this travel. All these dots are actually this, parasitized. Okay. So obviously, as woolly apple aphid also, imported in New Zealand, but it was not successful. And then we thought that our system is a little bit better than New Zealand lab system, so we might be successful to import here and then breed here. And also, as I mentioned, the scab is done, and then interaction also reviewed and also reported. Now, the phase 2 proposal also is gone, and was submitted, and this was mainly for finalizing masters and also pesticide sustainability, and also target was to import Haringia, and also the benefit of mycorrhizal, fungi on insect, and also more agronomical performances. And finally, also mass trapping of codling moth also is, was an important issue. So this is more about using, again, plant host volatiles in combination with the pheromones. And that will actually complement the masters. The reason is, as I mentioned initially, that more, working thing like biological control agent, the mass trapping, and also mating disruption should work better than using only one system. Okay, so as when we submitted the phase 2 project, obviously we were told that the budget actually significantly cut, and that's why we have to cut also our work. And that's why with our limited resources, we resubmitted the project, where we will try to finalize the masters releases in 5 states, wherever the codling moth is a problem, including Queensland, New South Wales, South Australia, Tasmania, and Victoria. And also we'll also assess the pesticide sustainability, and these other 2 gone. And then also 5 years project cut to 4 years to meet the budget. Now we are waiting for approval on the projects. And now quickly, this mass trapping, what we did in 2013 and 14, we actually tested 5 different combinations of lures against the standard one. And from that one, actually, we picked up the best one, this is the best one. And that best one actually tested in the following year, or 14 and 15 season. And as you can see here, this is actually used in mating disruption block, and this is actually non-mating disruption block. This is the total number of males and females attracted and killed. And if you see this one, this is actually, the males and mating disruption and non-mating, and this is actually females. As you can see here, it was working perfectly until this, up to the 3rd week. And obviously, after that, it's plateaued, and it did not work very well. Maybe there are several reasons. 2 of them we can think about it. Probably we killed all females, but I'm not sure about it. However, on the other thing, the lures we used, especially the plant volatiles, must be, their life must be gone. So we did not actually. We actually used the same lures for the whole season. So as most of the plant volatiles, the chemistry is kind of little bit, it actually kind of becoming weak quicker. So that's why, there are 2 strategies we are thinking for the following season. And if you see, the way we, as a team, we are thinking that maybe this was, after these 3 weeks became very weak, and that's why it actually lost the attractiveness to the females. That's actually the strategy we are thinking for the next season. Okay, now, as I said that, this coming season, what we are planning to do, obviously, if we get the approval of our 2nd phase, so we'll try to complete, master's work, and that's actually very important for us to complete. The reason is we spend so much money and energy to understand how it's going to work in our field situation, and now we have to understand, or how actually we can make sure that this is not going to be another cane toad to our fruit industry. So we understood that this is very specific and is going to work only for codling moth control. And now we have to understand how they behave in the field, how actually they are dispersing, and also, kind of surviving in the winter condition, or we have to supplement them, this sort of thing. And then finally, also we have to understand we also have to understand for example, the mass trapping situation, as we mentioned, that we have to improve this plant host volatile's longevity, as if it is actually we can increase the longevity is lots useful to use it the whole season, or we have to maybe replace it every 2 to 3 weeks, whatever way it works. We'll try that one. And obviously, the final thing is that we have to make it cost effective. Otherwise, nobody's going to use it. We can do the science and publish paper, but unless and until you people are using it and get benefit, there is no fun. Okay, now, as a team, we are, so far is we are happy that we actually achieving our goal, which was mainly to give a package to the apple and pear industry where they can rely on biological control and also mass trapping of codling moths. And in that way, at least, is going to be, or giving them a softer options for this management of this codling moth. And finally, obviously, all these funding bodies. And then finally, most of the growers I dealt with, they were grateful to help us, and also they were very positive. Obviously, there are some risk involved. And I'm very grateful to the growers, especially who are involved in our projects. And thank you very, very much.